various industrial fields, such as the aero engine in the field of aerospace, wind turbine and gas turbine in the field of energy, and automobile transmission in the field of traffic. Even though the rotating machinery is diversified, it generally includes some common and essential rotating parts, such as rotors, rolling element bearings, and gears. A rolling element bearing is a component that carries loads by placing several rolling elements, such as bolts or rollers between two races. It includes three components: an inner race, an outer race, and several rolling elements. Rolling elements are able to reduce friction forces between the contracting parts. To fully inspect the conditions of rotating machines or rotating machinery, condition monitoring systems are applied to collect real-time data from machines. The amount of data collected has grown exponentially by multiple sensors after one-time operation. Such explosion of data makes the mechanical fault diagnosis endorse the concept of big data. Therefore, the power of mechanical big data not only promise to challenge the traditional mechanical fault diagnosis, but also bring to this field new perspectives to process and discover valuable information from such big data. Therefore, it becomes a new research subject to extract features from big data and accurately identify health conditions using advanced techniques. In this picture, you can see the experimental setup from Case Western Reserve University Data Center, Peering Data Center. On the right, you can see the block diagram of this experimental setup. The data were collected from motor driving mechanical system under three different loads with sampling frequency 48 kHz. The bearing dataset were collected from this experimental setup under normal condition, means no fault, with inner race fault, with outer race fault, and with roller fault. The faults were introduced into the drive bearing of the motor with the fault diameter 0.18, 0.36, and 0.54 millimeters. In the paper, we proposed two methods, where the first method, we used the wavelet transform decomposition in using only the low frequencies wavelet coefficients and ignoring all the higher frequencies wavelet coefficients. These signals are fed into the DNN to extract the features in the training dataset. The proposal method 2, using discrete Fourier transform to process the lower frequencies with wavelet coefficients and fed these signals into the DNN to train the DNN or to extract features from the DNN, and the classification bearing fault type is obtained from the DNN output for both proposed method. This procedure, the procedure is repeated several times using different wavelet decomposition levels to achieve maximum accuracy for the both method, to achieve the maximum accuracy with the shortest training time. Our implementation of the proposed method, there are 5 layers of the constructed DNN, which the number of units in the input layer is determined by the sample size. And the number of units in the first layer, the second layer, and the third layer are 900, 400, and 200 respectively. The number of units in the output layer is determined by the number of health conditions, or the bearing health conditions, which consists of 10 health conditions. We use a radio activation function in the head layers, and for the output layer we use softmax activation function. The proposed fault diagnosis method based on DNN was tested by 10 separate datasets, where the length of the window is fixed to 2400 data points and 200 samples in each dataset. Combined on the dataset to construct 2000 samples, 2000 combine all the datasets to construct 2,000 samples, where 24 data points for each dataset is used. After shuffling, the combined dataset, 80% of samples is used to train the DNA, and the remaining samples is used for testing. The training dataset is fit into the DNA, where an unsupervised learning algorithm called an autoencoder is used to train to extract features of the training dataset with the unlabeled training dataset. After the training, to train the head layers actually, after the training is finished, the backpropagation algorithm is used to reduce the loss function and update weights of the learning parameters with the testing to achieve fine tuning after all the head layers are trained with the labeled training dataset. A detailed overview of the datasets is shown in this table. 0 means no fault, 3 different types of faults with 3 different fault parameters, 10 conditions various datasets, as we said. The experiments are carried out using the same implementation approaches proposed in reference A and compared to our proposed method using MATLAB 2050 in a machine with the CPU Core i7 runs at 1.8 GHz with 8 GB RAM. The output of the DNN is the predicted levels, where the output is a 10 by 1200 matrix, where 10 represent the number of health conditions and 1200 represent the number of testing examples, which means every column in this matrix represents a single testing example. The best testing accuracy using proposed method 1 was 88.6%, and using the proposed method 2, the best testing accuracy was 99.38%. While the proposed method in the reference A, the best testing accuracy was 97.5%. The training time for both proposed method 1 and proposed method 2 was 6.5 minutes. The training time for the proposed method in reference A was 1.3 hours. Conclusion, we proposed a method that used time domain and frequency domain analysis using wavelet transform decomposition and frequency domain analysis using discrete Fourier transform with deep learning, and compare our proposed method to a method that using only frequency domain analysis, discrete Fourier transform with deep learning. Our proposed method achieved high accuracy with the short training time compared to the proposed method and in the proposed method in reference A. Why training time is important? Training time is important because if the results is not what you expected, you can try other ideas in your neural network to achieve what you want from your neural network. I hope I didn't take too much time, and thank you for your attention.
Thank you.